So yesterday we looked at molecules, a bunch of facts about molecules, and then how to name them. All right, how to name all the covalent compounds. The other half of this unit is having a little bit more fun with the molecules and actually drawing them. If you look at the bottom of the front of your cheat sheet, you'll see a section titled VSEPR. That stands for valence shell electron pair repulsion. Here's what we know for sure about electrons, is when you start to force electrons near each other, they actually try to repel away from each other when you're just talking about electrons. If you think back to ionics, the reason that ionic compounds formed was because opposites attract. Opposites want to be together. But when you're talking about a bunch of electrons being near each other, well, this is not opposite. It's a bunch of same charges. And while we have the saying that opposites attract, there's another saying that like repels. Here's my point. If we have an atom that's going to have electrons around it, the electrons are always going to orient themselves like this, because if this electron tries to get any further away from him, he would start getting closer to that guy. And the electrons overall physically don't want to be very close to each other if they don't have to be. The furthest this electron can get from both of these guys is this exact point. Now, with this basic belief, we can predict shapes that they'll take. When different atoms are bonding together and their electrons are interacting, we can come up with some different geometries that the molecules will configure in. Flip to the back of your cheat sheet. And on there, you'll see some pictures drawn at the bottom. We're going to be classifying some shapes today, but first we have to know how to draw them. We're going to be representing some bonds today, and I need you to know what the bonds represent. When I say a bond, it's going to be like when I have two elements that are going to join together covalently, we're going to represent that with a line. You need to know what the lines mean. So in our molecular pictures that we're going to draw, every line actually equals 2 electrons. Now, this would be considered a single bond because it's just a single line, but you'll see that sometimes they'll actually form double bonds. How many total electrons do you think are represented in a double bond? Yeah, 4. If every line is 2, well then 2 lines would represent 4. The biggest type of bond you can have is a triple bond. How many electrons does a triple bond represent? 6. Every line is 2. So you'll see these different variations show up in our pictures today as we start bonding nonmetals together. Remember, it'll only be nonmetals because that's the definition of a covalent compound. On your cheat sheet on the back here, there's a step-by-step written out for you on how to draw these pictures. So reference that when you need to. As I teach these different steps. Make sure you've got plenty of space in your notes. We're going to draw some molecules. Somebody say that compound. CH4. Somebody name him.
carbon tetra
hydride, not hydroxide. Hydroxide has an ox in it. All right, but it's carbon tetrahydride from yesterday. Very good. But we already know how to name it. Some of y'all sound like you're either tired or rusty. But now we want to know how to draw. I'm going to take a look at our step-by-step on the cheat sheet. Step 1 says count up the total valence electrons in the compound. Well, here's how I'm going to do that. You see the CH4? I'm going to break him up into his parts. I see 1 carbon, and how many hydrogens? 4. 1, 2, 3, 4. 1 carbon and 4 hydrogens. The step on our cheat sheet said that we need to count up the total number of valence electrons that we have here. Well, let's remember how to find valence electrons. You look at the group, the column number, and it tells you the number of valence electrons in the entire group, column. But remember, if it's one of the bigger groups, like everything in group 14 doesn't have 14 valence electrons, they have, come on, play along. Everything in group 14 doesn't have 14 valence electrons, they have just 4. So take a look at carbon's location. He's right here on your PT. How many valence electrons does carbon have? He's got 4 in group 14. What about hydrogen? How many valence electrons does hydrogen have? Just 1 over in group 1. Everybody see where I've gotten these numbers from? Now we're still on step 1, which just said how many total valence electrons are in the compound. How many total? Yep, we've got 8 in this one. So we've done step 1. Step 2. Choose a central atom. Pick the atom that's present in the least amount. Now, that's not looking at these numbers. Which of these elements do we have the least amount of? Carbon, right? We only have 1 carbon, and we've got 4 hydrogens. So here's what I'm going to do. I'm going to put carbon as my central atom. This first example will be rusty because you don't know what the final problem looks like yet. So bear with me. So I'm going to put carbon in the middle. Step 3, bond all other atoms using a single bond. All right, well, there's my other atoms. There's 4 hydrogens. It says to bond all of them to that central atom using single bonds. Hey, look at this picture I drew. How many total electrons are represented? How many total electrons are represented in this picture right now? 8. Here's how they came up with that. Remember just a little while ago, every line represents 2 electrons, right? So 2, 4, 6, 8. So keep that in mind as we go through the process. Step 4, add dots and possibly more bonds to satisfy the octet rule. Now, on this first example, we've got to do some learning real quick, so focus here. Here's the deal for the pictures. It's a puzzle. It's actually a lot of fun. The way it works is, let's never do this. Write this down. All elements require 8 dots around them, except hydrogen which requires only 2. Dots. And I'll make sense of it in a moment. Let's go back to the picture. What you just wrote said that all the elements on the periodic table, every single one, when they show up in a picture, need 8 dots touching them, except hydrogens, which only need 2. Look at this hydrogen right here. How many dots are touching him right now? 2. Remember, every single line represents 2. So this is what we call a happy hydrogen, because hydrogen only wants 2. He's our special guy. How many dots does that hydrogen have touching him? Him? All the hydrogens are happy, but hydrogen's the only guy that's happy with 2. All the other elements require 8. How many dots are touching that carbon? 8. 2, 4, 6, 8. Now the puzzle is while keeping track of that rule, of this rule here, you also have to draw exactly the number of valence electrons from step 1. Now this was a really easy first example. I'll show you how they get a little more interesting. But we've done a good job. We drew 8 total dots while making everybody stable. Look further down on your cheat sheet. You'll see 5 different geometric shapes. This part's actually fairly easy in my opinion because the right answer will usually jump out at you. You want to go straight down that list the way I have it listed and compare the picture to those 5 descriptions. First off, you'll see that bent is your first option. The description for bent is a central atom that's got lone pairs on it. Now guys, lone pairs, your cheat sheet gives you this definition. But lone pairs are when you have actual dots that aren't bonded to anything. Are there dots, visual dots, anywhere in this picture? No, everything's a bond. So this is not a bent shape. Tetrahedral is a central atom bonded to 4 other atoms. Does that look good here? A central atom bonded to 4 other atoms. This is a tetrahedral shape. So there's our rocky first example. Now you'll start to see how this works. Let's do another one. Let's do nitrogen trihydride. Reading straight off the cheat sheet, step 1. We need to know the total number of valence electrons in the compound. I'm going to do that by breaking him up into his parts, 1 nitrogen and 3 hydrogens. How many valence electrons does nitrogen have? 5. Group 15 is 5. How many valence electrons does each hydrogen have? 1. Group 1 is 1. When I add these up, it will equal 8. And that's just a coincidence. This number can be any number. I know 8 jumps out at you as being like the chemistry number, but you'll see it be some larger numbers. Step 2, pick a central atom. Who are we going to stick in the middle of our picture? Nitrogen, whichever we have the least amount of. There's only one nitrogen, so he'll be our middle guy. There he is. Step 3, bond everything else using single bonds. We've got 3 guys here, so watch. 1, 2, 3. I don't care which 3 sides you choose. And the final step says make everybody happy. Add dots if you need to add dots. Add more bonds if you need to add more bonds. We'll see what all that looks like in a moment. Well, let's take a look at who's happy and who's not. Is that hydrogen happy? He is. Remember, hydrogen only wants 2 dots. All right? And that hydrogen has exactly 2. Each line represents 2. Is that hydrogen happy? Is he happy? All the hydrogens are good, all right? What about nitrogen? Is he happy? He's not. Let's take a look at why he's not. He currently has 2, 4, 6 dots touching him. Well, that's no good because we know all the elements require 8 to be touching him. So we're not good. We're not done. How many total dots am I supposed to draw in my picture? The whole picture should have 8. That's the whole point of that first step. How many have I drawn? So I still have 2 more I can draw. Where should I put those other 2 dots? On the bottom, right? That's called a lone pair. But now I've satisfied both parts of the puzzle. I've drawn the total number of dots I have to draw, and I made both of these rules totally happy. Nitrogen's now surrounded by 2, 4, 6, 8 dots. That's a lone pair. Classify his shape. Go look at your list of 5 geometric shapes. The 4th one, trigonal pyramidal, is how you say that. Trigonal pyramidal. The description matches up perfectly. It says a central atom with 1 lone pair. Any major fires for me to put out before I continue? This skill will take practice, but it's kind of fun. You don't let yourself get frustrated. Let's do water. Water's good. Step 1, count valence electrons. I've got 2 H's, 2 H's, and an O. It's what Santa Claus says when he stutters. You get it? How many valence electrons do those hydrogens have? Yep, 1 apiece because they're in group 1. Everybody see where I'm getting that? Valence electrons is an old skill. What about oxygen? How many valence electrons does he have? From group 16, he's got 6. 6 plus 1 is 8 again. I promise that's still a coincidence. Just starting you off with easier ones. Who will your central atom be? Oxygen, because there's less of him. So I'm going to put O right there in the middle. bond the leftovers with single bonds. Well, the leftovers are just two H's. How many dots have I drawn so far? 4. 1, 2, 3, 4, right? How many dots must I draw? So we need to draw 4 more dots. Let's see if we can figure out where they need to go. Who's happy in my picture right now? Both of the hydrogens are good to go. Both of the hydrogens have the 2 that they require, but oxygen is missing how many? None. Right now he's got 2, 4, and he wants 8. So he needs 4 more. So this works out nicely. We're missing 4 dots. Oxygen wants 4 more dots. Add them where you think they should go, and then classify his shape. Add the dots where you think they should go, and classify his shape. Where did you put the dots? On the top and bottom. How many up top? There's a lone pair. How many on bottom? There's a lone pair. We have drawn 2, 4, 6, 8 dots. That's the right number. Oxygen has 8 touching him. That makes him happy. The hydrogens each have 2. That makes them happy. What shape is he? He's bent. Because it perfectly matches the description of a central atom with 2 lone pairs. What do you think? There's a twist on this. There's a harder type of problem. So don't lose your focus now as I show it to you. Take a look at oxygen. Can I write oxygen like that? Why can't I not? Because why? It's by itself. What's the word? It's diatomic. Oxygen is one of the 7 diatomic molecules that can't exist by himself. So when I say we're going to draw oxygen, it must be O2, because you can never just have O. Let's make our list. All right, we're dealing with 2 oxygens. We need a valence electron count. How many valence electrons does each oxygen have? 6 apiece, because they're in group 16. How many total dots will we draw this time? 12. Well, there's a different number. Pick a central atom. Well, there's only 2 things here. You can't put something in the middle when you only have 2 items. So I'm just going to bond them together. There they are. There's my 2 oxygens. Now, let's make everything happy. How many dots does each oxygen want around it? They want 8. So if you're not writing in pencil right now, you might want to swap to pencil. Sorry, I should have said that at the beginning of the lecture. Or just leave yourself plenty of space to redraw your picture. But here's what I say you do. How many more dots does this oxygen want? He wants 6 more. I'm going to give him those 6. How many more dots does that oxygen want? 6, because right now he's only got 2. 3, 4, 5, 6, 7, 8. Now, each oxygen satisfies this rule. Somebody count, how many total dots have we drawn? 14. 2, 4, 6, 8, 10, 12, 14. Do you see the 14? How many dots am I allowed to draw? Dun, dun, dun. This is what makes this a harder problem. Now, when this happens, it's a very easy fix if you will listen to the one sentence I have to give you to fix it. It's written on your cheat sheet also. But here's what happens. If you have too many dots drawn when everything's happy, you erase 4 of them. Erase 4 of them and add an additional bond. Watch what that looks like. Watch. I said erase 4 of them. Now I suggest to do it symmetrically. So 1, 2, 3, 4. And add a new bond. Again, that sentence is written word for word on your cheat sheet. You don't have to memorize it yet. But look what that did. I now have a total of 2, 4, 6, 8, 10, 12 dots like I'm supposed to. And look at that oxygen. How many dots are touching him now? 8. Remember, that double bond right there represents 4 electrons. So he's got 1, 2, 3, 4, 5, 6, 7, 8. And so does that oxygen. By using the erase 4 dots, add 1 bond rule, I reduced the number of dots I draw because I needed to. I had too many. And it satisfied the octet. And if you can catch on to that one little rule, then I have now shown you everything that can happen. What shape is he? He's linear. That linear option on your shapes, I use it as the trash can option. If it's not one of the first 4, it's going to be linear. And a lot of times, double and triple bonds will be found. Let's do another one. Sulfur trioxide. Sulfur trioxide. Make your list. So, how many valence electrons does sulfur have? 6 from group 16. How many does oxygen have? 6 from group 16. How many dots are we going to draw? A bunch. We need 24 dots in this picture. It will be exciting and fun. What will the central atom be? Sulfur. There's less sulfur, so I'm going to put him in the middle. There's only one of him. And then you bond all the leftover stuff to him using single bonds. Is anything happy right now? Nothing is. There's no hydrogen, so 2 is not good anywhere. And nobody has 8. So, again, pencils are your friend. Make everything happy. All right, this oxygen only has 2, so I'm going to give him 6 more. All the oxygens are in that situation. So I'm going to add a bunch of dots just to make everybody happy. And then there's sulfur. How many dots is he missing to be happy? Yeah, just 2. And everything is currently surrounded by 8. Do you see that? There's an octet everywhere. How many total dots have I drawn? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. That's no good, right? How do we fix it? Erase 4 and add a bond. So I need to erase 4. Now watch. Here's where it takes some practice because there's a bunch of dots. Which 4 do you erase? You should always take 2 of them off that central atom. And this will just take practice. I still need to erase 2 more. I don't care where you erase the other 2, but whichever oxygen you choose to steal from needs to be the oxygen that you give the bond to. So let's just say that you're in the mood to mess with that oxygen. Well, now I've erased 4 dots. And when I add my bond somewhere, I'm going to do it to the oxygen that I have affected previously. Two, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 total dots. Hooray. This oxygen has 2, 4, 6, 8. Oxygen, 2, 4, 6, 8. Sulfur, watch. 2, 4, 6, 8. Oxygen, 2, 4, 6, 8. Do you see it? Everybody's stable. Everybody's beautiful. Especially me. What shape is this molecule? Trigonal planar. If you look at the description, trigonal planar says a central atom bonded to 3 atoms, and there's no lone pairs on the central atom. I wish we weren't on flex schedule. Don't put your stuff away. I would have you do this last one by yourself, but we don't have enough time for that because we're up against the clock. So I'll work through this one with you quickly, but nitrogen's even more interesting. Nitrogen is diatomic. He cannot exist by himself, so he's N2. If I make my list, nitrogen is in group 15. Therefore, he's got 5 valence electrons. That gives me a total dot drawing of 10. There won't be a central atom because there's only 2 items. So I'll just bond them together. And then add dots to make everybody happy. In my picture, both nitrogens are surrounded by 8 like they want to be, but let's check our count. 2, 4, 6, 8, 10, 12, 14. That's no good. To fix it, erase 4 dots, add 1 bond. What that rule actually does, guys, is it makes sure that everything stays happy as you start manipulating numbers. If you make everything happy and then follow that rule, everything will stay in the octet, which is really good. 2, 4, 6, 8, 10, 12. We still have a problem, though. We did it, and we're still not fixed. What do you think my suggestion will be? Erase 4 dots. Add 1 bond. Remember, this triple bond guy does exist, representing 6 electrons. Two, 4, 6, 8, 10, and then look at the individual nitrogens. This nitrogen has 2, 4, 6, 8 on him, as does that one. And now everybody is happy. Computer day tomorrow for more practice. Y'all have a good day.